will start today's session. So yesterday, a quick recap. We have discussed about decision tree algorithm, regression trees. Regression trees, CART is nothing but classification and regression trees. Regression trees is nothing but predicting the numerical values. For example, like house prices, salary, stock price. So it is basically predicting the numerical values. Classification technique is nothing but it is a binary classification, either 0 or 1. Example, the person has disease or not, or can the person purchase this product or not. So these are comes under classification techniques. So there are two different trees. Yesterday we discussed about regression trees and random forest regression. Today we are going to study about classification trees as well as random forest classification tree. So after that, we plan to discuss on SVM is another classification method, very popular one. We will discuss that also. Like I said, in the classification tree, your output is either 0 or 1, isn't it? Red dots are, you can take it as 0, or green dots are 1. What is this x1 and x2? These x1 and x2 are independent variables or features. We are not using y. Y means the dependent variable here. We are not showing the dependent variable here because it is a two-dimensional graph. So we are plotting this graph based on the features. We have two features. One is x1 and x2, and we are plotting a scatter plot in this, and you will get a dots like this. So the red dot representing 0 and the green dot representing 1. For example, we take like that. And how the classification is done on the data set, that we will see. So it is similar to the regression techniques. It is split the data set into many groups, or we call that as leaves. How the split is taking place is based on the maximum number of data sets. For example, here the red data sets are very high. Here the green data sets are very high. So based on that only it will split, or when you talk about technically, it is using the information entropy. I said that the same information entropy is used here to classify, to split the data set. By general term, if you want to say, means it is grouping based on the maximum number of red dots and green dots. In the split 2, we will see that more clearly. From this, where the split 2 will come is where the more green dots are there is here, and where the more red dots are is here. So basically it is splitting by. After that, this is green dots. That means 1 in the data set, and this is 0 in the data set. So there is no more splitting here. And if you come here, you will have the red dots as well as green dots. So we need another split here. So the algorithm sees like that, and it will split. So here the maximum red dots is there in the leaf, and again it will see all the splits. If there is no split is needed in this group, and for this also no split is needed. Here also no split is needed. But when you look at here you have both 0 and 1. That means red dot and green dots are available. So the algorithm will split based on that. So when it split, it has split number 4. Okay. So it is based on maximizing the number of red and green dots. When you see all the split, you have maximum number of red dots. Here also maximum number of red dots. Here maximum number of green dots. Here also maximum number of green dots. Here maximum number of red dots. So based on that only it is splitting. Okay. So this is how this decision tree will work. Why it is called tree means it is based on the it is a tree-like structure. If you see in that another dimension, it looks like a tree-like structure. You can see here, first split is around x2 greater than 60 or x2 less than 60. Okay, that is the decision. So when you look at here, x2 less than 60, if it is yes, it comes to this side, the branch comes to this side branch. And if x2 is greater than 60, that means this branch. Okay. Again, the split 2. When you come into the split 2, it is in the region x2 greater than 60. In that x2 greater than 60, you have two split. What is that split? X1 less than 50 or x2 greater than 50. When you see in the tree format, in the region x2 greater than 60, that is this region, there is one more split, one more decision it has to do, that is x1 less than 50. If x1 is less than 50, it goes to yes. And if x1 greater than 50, it goes to no. And then no more split is needed here because it is all green and it is all red. That's why the split stops here. Okay. So this is the end of this tree. So you can see there is two decisions it is taking, and you have the depth of the tree is 2. Okay. And you can see in the other side. So let's see where any more split is there in that side means you have the split. And where the split comes is x2 less than 60 and x1 greater than 70 or x1 greater than less than 70. When you look at here, when x1 is less than 70, all red comes into the picture. But here you cannot take the decision because there is more red and green dots are there. So again, one more split is there at that is called split 4. In the split 4, you can see the decision is x2 less than 20 and you have two more branches. Okay, so these are called branches and these are called leaves. Okay, so like that the decision tree is formed. So this is one tree, okay, based on the decision. That's why it is called decision tree. Here we are not averaging the values, we are classifying the data sets because it is either 0 or 1. Since it is called decision tree classifier. In the yesterday class, we call that as decision tree regression, where each split as average value of each split is taken and then it is fixed into that data set. Yesterday class we have seen. So that's all about decision tree, okay, tree classifier algorithm. Now we move on to the coding part. Okay, so first one is importing the library, and the second step is data set, and the third step is splitting the independent variable and dependent variable, and the fourth one is splitting the data set into training set and test set for testing and evaluation, and the fifth step is training, and the sixth step is predicting the test result. Okay, I'll keep this because this is evaluation method, and this is also I'm keeping it. Okay, these are common. Now we will work on this decision tree classification algorithm. Okay. There is no much changes in this code. So the first day what I thought, second day, and the remaining days I am following the same format. I am not changing the format. The reason is all are supervised algorithm. Only variation is it may be a classification method or it may be a regression. Okay, so that is the only difference. And another difference is the data set. The data set may be different forms. So for that, we need to do some pre-processing and encoding. If needed, we have to do it. Otherwise, we will use the same. We will other elements of forming. So that's why there will not be any, there will be much difference. Okay. So that will be the case. And when you go for the unsupervised algorithm and reinforcement algorithm, we will have different methods for that. Okay. Now we will import the libraries. What are the three basic libraries that we use for the machine learning algorithm is NumPy for handling the array. And the next algorithm is matplotlib. I'll just zoom it a little bit. Dot pyplot. Before that, just connect it. When you connect it, the notebook will be connected to our server and it gives some suggestions for you. That's the beauty of Google Colab. You no need to install any library function externally. Another one is import pandas as PD for handling the table. Okay, just run it. The thing is, all the libraries are included in the notebook, and the data set that I am interested is credit card. Okay, so we can use the other classification data set also. I will tell you in the working session. Credit data. Just upload the credit data on your notebook, copy the path, and we have to create the code cell here. Keep the name as data set read underscore CSV. Open the braces, open the codes, and copy the path, paste the path. That's all. Now your data set has been uploaded. The next step is if you want to see any function, the head, tail, how many data sets are there, we can see data set dot head. You say we have the 5 columns. What are the columns? Just see this one. First one is client ID. The second one is income. Third one is age. Fourth column is loan. And this one is LTI. And this one is default. Okay. So what this data set says is it is a credit data. That means the company was looking, the bank was looking to give the credit card to the customer. So for that, they are analyzing the database. So they are taking the income as one of the feature, their age as one feature. Is there are they are availing any loan? Okay, how much of loan they are availing? So that is also they are taking into account. And their score is there, no credit score or some score is there, no, in the banking sector. So that is the performance code is there. So that is also there. Okay, and finally the default. Default means 0. 0 is the 0 and 1. Okay, either you can give or you cannot give. So here 0 you cannot give and 1 you can give. Okay, so like that. So this is the data set. And how many rows are there? Just we look at it. What is the function for that is we can look at the shape. Okay, and the shape is 2000 rows and 6 columns. Okay, so that is the shape. Other thing was there, is there any null is there? If you want, you can look at it and you can have the information also. So these are common. If you want, you can check. I know it is there is no null is there. So it's a clean data only. I'm not going to do that. I'm just moving on to the splitting plot. Okay. So very interesting here is we have client ID and then income, age, loan, and LTA. Based on that only we are determining whether this customer, whether we can give or not. Okay, default means is having some problem. 0 means is not having any problem, we can give. So that is the case. And for that, the client ID is not needed. because it is just a number or ID. It will not impact the default. Okay. So it will not impact this 0 and 1. So I'm going to remove the client ID as well as the default column for independent variable. So how am I going to do that is x equal to data set dot drop. I'm going to drop the columns. What are the columns I'm going to drop is 2 columns I'm going to drop. So that means I have to open the square bracket, and then the first is client ID. So the name should be very, it should be same case sensitive also. So that's the reason. After that, comma, another column is head. Another column is default. Okay. So this is the target one. So I no need that. And then comma axis equal to 1. That means the entire column I'm going to drop from the data set. By showing some error. Okay, now it is clear. After that, I'm going to have y. Going to take y equal to, that is the dependent variable, data set on the braces and the default. So this is the column that I'm going to use in the target. Let's run it. If you want to see that, you can insert the code. You can print X or just X is also, it will automatically understand it is a printing. So you can see now the client ID is removed, income, age, loan, and LTA is there for all the 2000 data. Okay. Next is splitting the data set into training set and test set. I already told what is the reason for that, why I need to split, because some of the data, that means around 80% of the data we are keeping for training and 20% of the data we are keeping for testing with the actual value. After that, we will combine both the things and then we will check how much the accuracy the model is. Okay. So I'm just copying the code directly because it is directly there in the sklearn. So from sklearn model selection import training test split. So X train, X test, Y train, Y test. Okay, so this is the default format. Train test split is the function. We are splitting that X, Y. Test size is 0.25. That means 25% we are going to use for test and random state to maintain the uniformity in the selection of the samples of the data set for the train and test. Okay. And then run the train. You have the X train. This is the X train. 1500 is taken for X train and Y train is the corresponding default column and X test is the 500 rows. Remaining 500 rows is taken for test and that corresponding Y test. So this is all about splitting. After that, feature scaling. Is that any feature scaling is needed? One is, I said you should not use feature scaling in the decision trees because the classification, the splitting is based on the information of your data set. If you do the feature scaling, then it is difficult for splitting the data. So that is one of the thing you have to remember. For logistic regression or linear regression or any other algorithm, we can use the feature scaling, but it is preferable that we should not use the decision. If you use the feature scaling also, scaling means what? It may be a standard scaler or normalization technique to make the range equal. Okay. So if you want to use, we can use, but you tell me, is there any improvement in the analysis or not? I don't think it will improve the performance of the algorithm. So that's why we are leaving them. Okay. And then the next step is future scale. We are skipping in this case. Then we are moving on to the training the decision tree classification model on the training set. Okay. So where it is? It is on the sklearn. Okay. In the Google, you type sklearn decision tree classifier. So why I'm using all those things is, if you want further, you want to learn about the algorithms or any other algorithms you want to learn, is you just go through this process. Okay. So here you can see sklearn examples and the explanation about the algorithm. As usual, take the command from here. So just search it. That's the way. So from here you can take this. Okay, from sklearn.tree, import decision tree classifier. Copy and paste it. And the next is open the classifier, that is a variable equal to the function decision tree classifier. In that, you have to mention the randomness and criterion, like that. Okay, so here you can see there is lots of things. There is different types of criterion. You can use Gini or you can use entropy, whatever it is. So I'm going to use entropy. So that's why I'm typing criterion entropy. There are different ways of classifying the splitting. Okay, so like I said, I'm using entropy. And then the next is random state. We have to maintain the random state. So here you can see the max depth, everything is there. So when you type, it will give the suggestion and then you will make it as 0. So random state you are making as 0, and min weight, the number of tree size. So everything you can mention. Okay, otherwise we make it as default, no problem. And another one is we have to train. How to train? That is the variable name dot fit. I'm going to fit means training function. I'm going to train with x train and y train. X train, you can here have the suggestions for that, and y underscore train. So x train and y train. Just run it. Your model is created. So we have done that. So this is how we have to create the model. Once the model is created, we are going to test and train. So how we are going to test? We have a test sample for that. That is x test. And I'm going to use the predict function. Predict function is to predict the output for this test value using the model classifier that we have created, and that result will be stored in y predict. And what I'm going to do is I'm reshaping it. Okay, what is this reshape function? So this is the first, always this first one represents the rows. -1 in the Python means all the rows. That means 500 rows. In the y predict means there is 500 samples here, right? 500 rows, and all this will be placed in a single column. Okay, we are converting that into a two-dimensional array. Okay. Similarly, the x test means actual value. So again, we are using the np.array numpy, and I'm reshaping that into another column. And then I am combining the array. How I'm combining the array? Using the np, that is a numpy, and concatenate. Concatenate means joining the two columns in a column wise manner. So that means in this format, yprate.array and ytest.array, and I'm making that in a single column. Okay, so print combined array. I'm just running this. You can see we have two columns in a array. That means two Two things. One is Y test, another one is Y prediction. First one is the prediction and second one is the actual value. So when you see this, almost 0, 0, that means the prediction as well as the actual are same. The prediction and the actual are same. When you go through it, actually it is done well for this data set. All are predicted correctly. Am I right? So it's amazing. Let's check it out. What is the percentage confusion matrix? So when you go for classification, we can use what? Confusion matrix and accuracy score. When you are calculating the numerical value, we have to go for R square or MSE. Okay. So it's a confusion matrix and accuracy score. These are the metrics in the sklearn. And confusion matrix is between Y test and Y predict. I already explained what is confusion matrix. Okay. And accuracy score is between the Y test and Y predict. Let's check it. What is that? Okay. Wow. So you can see here 436 the is predicted correctly. That means the Y predict is also 0 and Y test is also 0. And there is no error in this. And here only one error. Okay. Only one wrong prediction. So this diagonal is wrong prediction and this diagonal is correctly predicted. So out of 500 samples, only one sample is wrongly predicted. Other things are exactly correct prediction. Okay. So the percentage here is 99.8. It's a very good result of this decision tree. And then let's check it out with the our own values. Okay. I don't know the value of this one. So I'm just taking this from the row. Okay. The first row is 66.155, age is 59. I'm just going to check, or you can give any value. Okay. Because now the model is created, we can use the model for the application. Okay. So just copying this value. And then again, I'm going to convert that into array and I'm going to reshape it into 2-dimensional. So that is the common thing. After that, I'm going to predict with the predict classifier and then prediction is taking place. If it is 0, the client is not default, you can give the loan. And if it is, or you can give the credit card. And if the client is default means you should not give because already the client is not good. The performance of the client is not good. So just click over it. It says the client is not default. Here it is 0. Here also you can see it is 0. Okay. So amazingly it works well. Okay. So that's how this decision tree will work. So here you can see random forest, tree and forest. From that itself we can understand. Multiple trees are called forest. In forest you have multiple trees. And randomness means the trees are not similar. It may be of any kind. Okay. So different trees, multiple trees is called random forest. In decision tree, you will have only one tree. Okay. But here you have multiple trees of different types as well as the forest and that's why it is called forest. Okay, random forest. It comes under ensemble learning. Ensemble learning means instead of doing one tree, we are going to have multiple trees. Finally, the average of all the trees will be taken and used for the prediction. So in that way, we can create the robustness in the algorithm. Okay. So what is the step is pick a random k data points from the training set, build a decision tree associated to this k data points, choose the n number of trees you want to build, choose the n number of trees you want to build and repeat steps 1 and 2. So I have to determine how many trees I want to use. Okay. After that, for a new data point, once you trained that, for a new data point, make each one of your entries. Okay. When new data point is coming, the model will each one of the trees, that means n trees, if you take 100 trees, the 100 trees will predict the values for this data point. Okay. And then finally, the average of all those things, okay, the point to the majority. Okay, it will take the majority of that and then it will decide. Okay. So point to the category that wins the majority. Okay. So it's a very interesting one. The one thing is it definitely it will increase the accuracy and it increases the and the drawback is we have to do more number of trees. Okay. So for huge data set, this might be a problem. Okay. It may take more time. Okay. So that's all the working of this one. It's a tree, but we have to do it in multiple. Open the code. So you can do now like yesterday. Only thing is we need to change the algorithm. Code is available there for you for reference. Credit card random classifier. So already it is 99.8%. I don't think it will increase further. But anyway, we will learn that. Okay. Okay. So upload the data set first. The same thing. Only thing is you need to change the algorithm. This random forest. The same data set we can use. Okay, I just quickly go. And this is the library functions, NumPy, Matplotlib, and Pandas. Okay. And then I am reading the CSV file and it is stored in the data set. So now data set is your data. And then I am separating the independent variable and dependent variable. I am removing the two columns that is not needed for me in the input side. So I'm just removing it. And then for Y, I'm keeping only default column on the data set. That is your target. I'm just running it. After that, I'm splitting the data into training set and test set. And the same 75% we can take. So you should not take more for testing. Okay, for training, we have to take more. Then only for testing, we have to take less number of samples. It is around 20 to 25% is enough. Maximum we can go for 30. So if the data set is very huge, otherwise you just maintain the default value. Okay, that is 20 to 25%. If you train with less data, obviously the performance will not be good. So first we have to learn well, then only we can do the test. If you're not learning, then we will make errors on the test. Okay, so I'm just checking out all the parameters. Just I'm closing it. And future scaling is not needed. And you can look at here, this is the random forest classifier. So here you can learn some important things. Okay, how to get this is sklearn random forest classifier. If you put, you can see that function. In that random forest classifier, we have some parameters. What is this parameters? Like I said yesterday, estimators is number of trees. How many trees I'm going to take is 10. You want 100 or 50, you can give any number over here. So this is number of trees. Criteria, what I'm going to do is entropy. So there is other criterion also there. Okay, but I'm interested in entropy. Okay, if you want to try with other criterion also, you can do. And random state is 0. As usual, I'm maintaining that. And then I'm training the data with X-train and Y-train. So this is the only area that I'm going to change. Okay, that means I'm going to do the tree algorithm for 10 times of different data. Just running it. After that, predicting the test values. You can see the columns, it's almost the same. Okay, there is no difference, 0, 0. That means the predicted value and the test value are same. Let's check the confusion matrix. Again, there is no difference here, just only one error. There will be some exception, isn't it? And there is, if you want to check means, it's also the same result, obviously. Okay. So that's all about random forest classifier also. So when you need more accuracy, in case the accuracy is not good in the decision tree algorithm, then we can use the random forest algorithm for that, and we can increase the number of trees if you want. Yesterday's class, we have seen that in the random forest regression, when you increase the number of trees, the accuracy has increased a little bit. Okay, so since these data are cleaned data, these data are used for learning purpose. When you take any random data or any data from website or like that, then you have to do some data pre-processing, and there you have to work with the parameters like number of estimators, because their data is uh, not clean. Okay, so here it is available data, so the performance also good. So that's all about this random forest classifier. Okay, we will start support vector machine. Support vector machine. It's very interesting algorithm, this one. We'll just look at it. No problem. Here also you have two independent variables x1 and x2 in a two-dimensional scatter plot. You have two groups here. It's a classification technique. We have to classify that into groups. So in decision tree, we are using splitting, horizontal, vertical lines we have used. But in this SVM, we may use any kind of split. It may be like this, or it may be like this, horizontal, or it may be a diagonal, or it may be diagonal of any slope. Okay. Any form of split, if you want to make in a data set, then we can use support vector machine algorithm. Okay. And then the next part is, if it is not if it is not separable, then we can use hyperparameters also. Hyperparameter means increasing the dimension. We can increase the dimension and then we can able to separate it also. That is also possible here. So anyway, this it has some flexibility in classifying the data set. How the flexibility comes is because of the simplicity of this algorithm. What is the simplicity of this algorithm is, it will consider only the two extreme margins of the data sets. Okay, it will search for the maximum margin. What is maximum margin means? If you take these 2 points, the margin is not maximum. If you take these 2 points for classifying, if you want to draw a line over here like this, okay, if you want to draw a line over here, imagine these two are, imagine these two are green. Okay, so we cannot do like that because this is the data set, right? So this is red and this is green. When you look at this data set, the maximum margin occurs between these 2 points. Okay, in between that there is no point. Between these 2 points, you will have the maximum margin. Okay, and we have a line. Are able to understand this? It will consider the 2 data points that will produce the maximum margin from 2 different classes here. We call these 2 points as support vectors. That's why the support vector machine, okay, algorithm. So it will check these, we can call this as support vectors. Based on these two data points only, the maximum margin and this hyperplane has been formed. So this is called hyperplane. Okay, this is called hyperplane, and that hyperplane is based on these two support vectors. Okay, and there is a line. This is the margin of that. So this is how the data has been classified into two classes, either 0 or 1. Okay. If you remove this data, these data points, okay, if you remove this one, and if you remove all these data points, then also the maximum margin, the hyperplane will not change, because this hyperplane is basically, this line is basically depends on these two vectors only, these two data points only. It is not depend on other data points in this green or other data points in this red. Okay, so it is basically depends on this two data points. Okay, so this point is called positive hyperplane, and this point is called negative hyperplane, and these two are support vectors, and this is the maximum margin. In that way, the support vector machines will work. Why these 2 points are very important? Okay, we will see that what these 2 points things with an example. We have we have a picture here. One is apple, another one is orange. Okay, apple has some shape and size. Similarly, orange has some shape, size, and color. Am I right? Okay, when you have the features of these two, we can say this is apple, x2 is apple, and x1 is orange. If you have a so two parameters, not x2 and x1 orange. X1 is one parameter and x2 has one parameter. If you have apple and if you have an orange in the data set, definitely apple or in this region, and orange or will be in this region. Okay, based on the features, because apple has some shape, color. So all these are formed a group here. And similarly, orange has some shape and color. All this formed a group here. In that group, you have a blue circle over here. This blue is nothing but standard apple size. So when you take a apple, it has some standard size and color. So all these are grouped here. Similarly, you will have some standard orange size and color, and these are grouped here. And we have some extreme points also. Okay, we have some different kinds of apples, different sizes of apples, not a standard size. So that points are away from this group, little bit away from this group. That is called extreme points. We call that as extreme points. Let's see in that example. So this is how, when you see this circle, this is the standard one. And we have some extreme also, some unexceptional, but it is an apple. Let's look at it. Okay. Similarly, orange and some unexceptional. So here you can see in the picture, it is a apple, but this apple is an orange color. Okay, some yellowish apple also there. So it's an extreme case. That apple will be in this point. Okay, that is called extreme points. Okay, so it is an apple, but it's look like a, but it's like in an orange color. So when you have that feature in the data set, definitely the data set will fix this data closer to this orange. Okay, okay, little bit away from the standard size. Similarly, when you look at this orange, there are some orange that will be in different color also. Maybe think as an apple, green apple. So that will be in this point. Okay, it will choose only the extreme points of these two data set, and then it will classify. Okay, it is not choosing this one. It is not choosing this one. It chooses only the extreme points of this two feature, two things. That means here apple and orange, and then it will fix a margin over there. Okay, So first point is it deals with the most extreme case. Support vector machine consider only the most extreme cases in the data. Okay, and then it performs the classification. Okay, that's the first thing. Second thing is it uses only two data. There are multiple data in the data set, but it uses only two data to classify the data sets, either it is an apple or orange. Okay, so these 2 points you have to keep in the mind. So where this SVM is more, why this SVM is more popular means, if you have a data set with a small amount of data, for example, where we have seen the thousands and like that, if you have 100, only 100 data set only available for me, but I have to perform I have to create one model, classification model for that. We can use what? SVM. Because for SVM, the classification needs only two data points. The remaining are not participating in the classification. That is one of the advantage. If you have a smaller amount of data set, the SVM will perform better when compared to other algorithms. It may be a decision tree or a random forest classifier or a logistic regressions that we have discussed so far. Okay, so that's why this SVM is more popular because it takes only the extreme cases in the data points in the data set. So that's all about SVM. It's very interesting one. Let's see how this SVM will perform. So the drawback is, what is the drawback in this one is, if you have a huge amount of data, that is of no use. Okay, because it deals only with the two extreme points it is taking and it takes the decision. May be wrong and it may be inaccurate also. Okay, so if you have huge amount of data means you can use all the knowledge and you can predict better. Okay, so then we will move on to the implementation part of this SVM. Okay, now we will discuss about this as usual. Just delete this one. Here also we will use the credit card. Okay, let's check it out. Or you can use any thing also, no problem. Future scaling we can use here. We can use the future scaling in the SVM. So I will keep it that. There also use the super scaling and then check. Without super scaling also you check and then calculate whether it is needed or okay. So this is SV. Okay, this will keep same, no problem. Okay, just we will look at into the algorithm quickly. Import numpy as np. Before that, connect it. It's asking me manage session. When you open more files and then upload the credit card data set. We can try different also. Today I have taken this credit card. I have sent many data sets to you. Just work on that. This credit card. Next is importing. Just copy the path, then close it. Open the ports, copy the path. Just run over it. And again, it's the same data. I'm not going to see the analysis on just skipping that. The next step is columns. That is also same. Data set dot drop. You also can work along with me and you can check the performance. Int ID default. If you want the name, just axis equal to 1. And let's check it. Correct. It's not good for learning. Quitting the training set and test set. Then move on to the other areas. That is the scale learn part. Future scaling I'm not introducing here. So that's for you to understand. Okay. You just work it on that. Scale learn dot now support vector machine or classifier. Okay. Let's go for classifier. Here you can see sklearn dot svm.svc. Here you can have lots of parameters. So this is what I'm saying. Okay. So if you want to do some modification here, then learn that and do. Otherwise, you make it default. No problem. Okay. So now we go to the example part. So there is some standard scalar from sklearn svm.svc. See, I am not applying any standard scalar here. That we have to do. Without that, we will check how the performance. Okay. The second line is we can use some of the parameters. Okay. Here for this example, they didn't use anything. Okay. If you go further and check, is there anything available? You can check. Otherwise, here some examples are there. You just go click and see what kind of example is there. There's lots of things to learn. So some graph, you can use some graph also to see the output for the data set. If you click this graph, you will have code for this. Okay. So you can use that code for that also. There's lots of it. Okay. The moment we will focus on this one, SVR class. So you can see the kernel, linear and random state 0. So what is that kernel linear? You will see what is that kernel. I went somewhere. So why the machine learning and algorithms are very popular today is we have huge number of library functions. Okay. See, here you can see the kernel. The first step itself, kernel. In the kernel, you will have different options. Okay, linear, polynomial, RBF, sigmoid, pre-computed. So there is lots of things.